All right, so before I tell you anything about myself, I'm going to start with a question. Can I grab this clicker over here? So here, like so. So, who remembers these things? Telephone albums, show of hands. Okay, there's a few. Has anybody actually still put any photographs in these things? All right, more than I thought. I thought I was going to be the only guy with my hand up here. But we don't do that anymore, right? Nowadays, everything's in the cloud. We take photographs on our cell phones, upload it straight away, got onto Facebook. We don't even sort the photographs anymore, do we? We actually let Facebook do it for us. We get the little video once a year, memories from last year, remember this guy. It's all done with machines now. We don't actually even sort anything manually anymore. So what does this got to do with monitoring? Well, first of all, these four guys started a company 7 years ago. A network engineer, a systems engineer, a coder, and a salesperson. Don't worry, I'm not a salesperson, I'm the coder. And we said, let's write a monitoring system that will collect everything off the network. And like photographs, we collect all the data and we sort it out after the fact, which turns out by some strange coincidence was a really cool idea because it allowed us to really become ISP focused. If you think about the ISP environment, like Cacti and those kind of open source tools often have a problem where you can't have guys, a whole team of guys actually provisioning every little monitoring aspect. You actually kind of want to collect everything. And then after the fact, you want to sort it out and then provide the stats to your customers. So that was pretty cool. We did some nice stuff over the last 7 years. We did some not so nice stuff over the last 7 years, and we did some really, really awful hacks. I'll be honest, over the last 7 years as well. But here we are, and we're still learning and doing new things. So, what is happening with monitoring anyway? So, it's basically a mountain of data. Nowadays, 10 years ago, we had routers with a couple of hundred interfaces. Now we've got routers with 10,000 plus interfaces. Even a baby router like a Juniper NRX80, for example, plus 10,000 interfaces. Now you want to collect network stats on their interface stats. You want to collect QoS stats. It takes a long time to poll these devices via SNMP. So SNMP is too slow for this stuff. It doesn't work anymore. We've got to look at something else. We look at a push versus the pull technology. SNMP obviously being pull. And push is kind of good. Like NetFlow is a push technology. It's kind of cool. We can collect a lot of nice stats from NetFlow, but it's too much data, actually. What we really need is real-time reporting. So like logs also kind of goes part of the way to sort it out, but not quite there yet. SDN also provides its own special challenges. Now we're looking at where virtual services can pop up and disappear off the network randomly without you knowing. You could have time to provision this stuff. You've got to collect those stats from those devices and those services right as they get provisioned and as they get torn down. And the reality is basically humans are too slow. We just can't keep up with this amount of data anymore. It's just too much, and we need some sort of layer between us and the network that can actually extrapolate the meaningful bits of all this data we collect and provide it to us in like meaningful terms that we can actually do something with. So why do I think telemetry is cool? Well, first of all, there's the streaming technology. So there's your push versus pull straight away. And streaming technology isn't new. It's been around for a long while. And it's way better than what we're trying to do with SNMP. I mean, get bulk is a pretty terrible way to collect data. We've tried this stuff on routers before with 10,000 plus interfaces, and we're looking at about 5-7 minutes to collect all those stats from routers. I mean, nobody can wait that long. It just doesn't work. So telemetry is cool because it does template-based config per device. And those guys have used netconf before, Juniper's fans. They'll love this. This is very, very easy to configure the telemetry sensors via netconf, push the config out to the device, and it'll start streaming data. And then you use JSON or the Google protocol buffers. You'd actually use compressed Google protocol buffers as well, which is actually the ideal way to collect the data because it's the smallest possible footprint you've got of UDP or TCP. You can actually use XML as well if you want, but I don't know who still does that. The Yang modeling is where the provisioning comes in. I mean, everybody who's used NetConf before is quite familiar with Yang, Juniper guys. So it's kind of using some of the familiar as well as some of the new, which is really great. And the nice thing, and probably the most positive step here, is because telemetry is kind of a new thing. The vendors are getting a little bit more on board with it. Anybody who's tried to write network monitoring software before will tell you vendors and SNMP, it will say the one thing in the MIB, but what happens in the real device is a whole other story. So vendors are kind of buying into telemetry a little bit more. In fact, Cisco have announced they're dropping SNMP support really in XR6. So in the next 6 months, we're looking to all the new features that are coming out on routers. No longer have any SNMP MIB released. It'll all be telemetry data. So here I've put together a little example of telemetry deployment. There's some open source telemetry probes I've put in there. I like Kafka as a nice aggregating layer because Kafka has got some really cool features, and it's nice to be able to use a single layer to aggregate all your data through. And then we've got the tech stack from InfluxDB. In fact, this whole first layer here, if I can just show you, if you download the OpenNTI project from GitHub, that'll be exactly what you get, that first line over there. It works pretty well. Grafana on the top. It's very useful to play to get to know the telemetry stuff, and it's pretty neat. There's also another way here, Cisco Pipeline, also does through Kafka, through Telegraph. And of course, you don't even have to go through Telegraph, you can go straight in InfluxDB as well. This is, I mean, it's not the be-all and end-all way of doing it, but it's just some of the ways you can put together these things. I like the modular approach, so I like to put together things as we need, like use the best possible collector to push it through to something like Kafka, Telegraph. InfluxDB I favor as a time series database. It's got some really cool features. I know a couple of people use some other technologies, Elasticsearch. Not so great on time series data, but it's pretty good at metadata. And one of the mistakes we actually made very in the beginning when we first started playing with Influx data was that we tried to put some of the text fields into the time series database. So that's a definite no-no. You choose up memory like crazy, and it's not really designed for that. So we found that the Elasticsearch for metadata, linking to actual integer fields in Influx data, works really, really well. Right, so what about storage? One of the other mistakes we made, and I think this is the biggest mistake anybody can make, is that you always underestimate how much data it's going to be. It's a lot of data. And even if you don't start out thinking, it's a little bit, you'll be surprised how quickly the data escalates, because you just add one more thing, and you add one more thing, and before you know it, you're running into problems. So it goes without saying that whatever solution you put together has to be horizontally scalable. If you can't put another node onto this solution, like you're going to hit trouble. Another problem is also partitioning data. And it's nice in our ideal world to think that you can just push the data into the system. Even like something like Influx or anything like that, you can push the data in and it'll just live there and everything will happen. But in reality, you can't do that. You have to partition your data. You have to choose up front what is going to be real-time accessible, what is going to be accessible in like larger time buckets. And most importantly, I think you also need the ability to be able to change those time buckets as you go, which was one of the choices that the reason we chose Influx. But you know, that's not the only solution. There are a lot of time series databases out there, a couple of them running. You can play with them in Docker containers, and you can try them out. There's some very nice, if you actually just search for, on Google, there's a very nice document on comparing all the different time series and which accept data in order, which accept data out of order, and so on. So basically just do some research around that and choose what's best. So is telemetry the silver bullet? I guess in the short answer, I'd say no, it isn't. Because the reality is, at the end of the day, vendors still need to actually implement the stuff correctly. You're no really better off than the SNMP way, except that it's now obviously streaming. You're still reliant on the vendor. You're still relying on stuff being done correctly. You're still relying on the Yang, the .proto files being correct. So we've taken like, the MIBs and we've said, okay, cool, we'll create these .proto files and we'll use this Yang modeling to collect the data and define it all. And we can only hope that actually it'll be okay. But definitely, I do think it's a step in the right direction. So here's some open source projects you can have a look at. I've played around a couple of these. They're pretty good. Or for the guys, it's quite a technical audience. So if you're truly hardcore, what you can do is you can just use Netcat and pipe it into a protocol decompiler, and you'll have a look. There's your telemetry data. It's pretty cool. And if you look very carefully, you might notice that it's kind of not too dissimilar from SNMP, actually. So it's something to play with. I hope I've interested you a little bit in the topic. I'd like to talk to you guys some more at the back. And don't forget the most important part. I have to mention this. Just do please come pick up your Iris socks. I don't know, any questions?
James? James from Jacques. Apparently I have to ask a question. Will it blend?
Will it blend? Nice. Cool. So thank you very much. And we've got a link up here on our site, and I'm sure you'll be able to download the stuff from LINX as well. And we'd love to hear from you. Find us at the stand. Come chat to us. Thank you very much.
Thank you, Jacques. Thank you. Thank you.